All right, thank you for the introduction. Hello, everybody. It's really nice to be able to join you from Newfoundland, Canada. I'm going to be switching gears a little bit and talking about only behavioral experiments. We're going to be talking about the influence of age and experience in how people use cues for auditory streaming. So we've talked a little bit about auditory streaming already today. We know that it's about describing, separating sounds into their respective sources, essentially. And it's influenced by a whole lot of aspects, both bottom up, things like frequency, tempo, location, and top down. So things like where you're paying attention, expectations, and musical training. And the reason why we looked into this is that we're looking into speech and noise. It's the most commonly reported hearing issue in older adults. And this is part of a bigger project where we're looking at what aspects of different cognitive tasks are maintained in music, particularly in old age. And auditory streaming is a critical component of understanding speech and noise, because of course, if you can't separate the speech from the noise around you, you can't understand what's going on. So far, there's been a little bit of research in this. Simple and tone-based sequential stream segregation seems to be preserved in older adults, but not concurrent stream segregation. So if like harmonics at the same time, those are more difficult. This evidence is both behavioral and neural so far. So just to give an example of some of the previous work in this, Snyder and Alain in 2007, did an ABA paradigm-based experiment with young, middle, and older adults. So the A and the B are two different pitches. The blank is a silence. And the A and B tones were either 0, 4, 7, or 12 semitones apart. And the participants were asked to indicate whether they heard one or two streams, and EEG was recorded for this one. And so we found the typical pattern where the further apart the tones were, the more likely participants were to hear two streams. It's fairly standard. But the interesting thing here is that there was no perceptual difference between the age groups. So that's what we're interested in. But this study and every other study so far has only looked at auditory streaming in terms of pitch. Now, another experiment that I came across a couple of years ago, I really like the design of it. It doesn't look at age, it looks at timbre and musicianship with streaming. So musicians and non-musicians rated the difficulty of perceiving a 4-note melody, which in the figure here is represented by the black note heads, while there were interleaved distractors, or the gray note heads, and those distractors were manipulated in terms of intensity, spectral envelope, and temporal envelope. And so part B of the figure illustrates the temporal manipulation, and part C, the spectral manipulation. And these are manipulated so that they were either the same as the target melody, which would make it very difficult to perceive the target, or increasingly different from the target melody, which would make it easier to perceive. And then a second experiment was a dissimilarity rating paradigm to establish a conceptual scale using multidimensional scaling. And so they found that essentially musicians needed less difference between the target and the distractors than non-musicians to successfully identify that 4-note melody. And that intensity was the parameter that led to the earliest streaming for musicians. Whereas for non-musicians, they needed both intensity and spectral envelope to achieve similar performance. And so combining those two things together, we decided to essentially replicate and extend the study. And so I want to talk a little bit about each of these streaming features and how it relates to aging so far. So in terms of intensity, long-term noise exposure, which is just common, and as we age, we're all exposed to noise. Do let me know if the construction is too loud on that note. Long-term noise exposure leads to loudness recruitment and loudness growth. In other words, perceiving sounds more loudly than those with less noise exposure, so younger adults. The thing is, if this is a constant change over time, there shouldn't really be a difference in performance in terms of using intensity as a streaming cue. So that's what we would expect from that. In terms of spectral envelope, there's very little research, as far as I found, on how spectral envelope changes perception with age. We did find one study that looked at melody and timbre recognition in younger and older adults, and there were various manipulations of different filters and things. But what matters here is that older listeners could not take advantage of the high frequency information where younger adults could, which isn't surprising given that just general hearing loss is more of a loss in a higher frequency range. And so we lose that information as we get older. Now, temporal envelope has a lot more information. Behavioral and neuroscience evidence suggests that older adults, they lose temporal precision, both in encoding sounds and in the perception of sound order. But most of this work exists in the speech perception domain, and less specifically for music. So as I said, the current study is a replication and an extension of Marozeau's work from earlier. We're extending it to older adults, essentially. So we're doing the same thing. Part one, older and younger musicians and non-musicians. They identified tone deviance in that 4-note melody amongst the distractor tones. So we changed the task just a little bit to make it a bit more objective. Instead of rating how easy or hard it was to hear that 4-note melody, 2 of the notes were switched. So here in the bracket, you could see instead of being G, C, A, D, it would be switch. And this happened 25% of the time and it was semi-randomly inserted. And then in part 2, they performed the similarity ratings between pairs of 4-note melodies again, so we could establish a common perceptual scale. And so some of the things that we expected to see was that poor temporal order and temporal precision encoding and also high frequency hearing loss may affect sequential streaming based on the manipulation of temporal and spectral envelope features. But if there is no age difference, then either there is no deficit when it comes to this music-based stimuli, or there might be compensatory mechanisms that are at work. We think that there's still going to be the effect of musicianship, so our musicians will need less difference in features than non-musicians. But the really interesting question that we had was whether there would be an interaction between age and musical training. Right, so does the advantage of musical training persist in old age? So to dive right into a little bit of the methods, these are descriptions of the stimuli. So the target had a set intensity, spectral envelope, and temporal envelope. The spectral envelope refers to attenuation of each harmonic, where there were 10 harmonics as part of each tone. And the distractors are manipulated in 20 different levels. So in terms of intensity, it was levels of 2 phons, and then spectral and temporal envelope were manipulated in just logarithmic scales. And so there were 6 blocks where one feature was manipulated at a time, and it was either of increasing difficulty or decreasing difficulty. So for example, an increasing intensity block would start off with the target being very different from the distractors, so it would be very easy to identify the target, and then for each 3 hits or 3 misses, the level would increase in difficulty, and so the lattice would get closer and closer to the target. In increasing blocks, if the participant could no longer perform the task, we did stop the block so they didn't have to sit through the whole thing. Unfortunately, this wasn't possible for decreasing because it started at the hardest and got easier and easier. And so those blocks were completed fully, always. So on the right side here, we see participant demographics. There was a clear difference between our age groups in age, clear difference in musical training based on the Gold MSI, and also a significant difference between pure tone average hearing thresholds. So in analysis, we did remove 1 participant who performed under chance in more than half the blocks. And like I said, some of the blocks were interrupted and we interpolated the missing data. And then we calculated the D prime score. And the analysis method was a linear mixed effects model for each feature separately, because we can't yet compare them directly. D prime was predicted by level, by age group, musical training, and pure tone average. Then we also used equivalence test to confirm whether null effects were indeed null, not different from 0, where that was relevant. So results of experiment number 1. What we have plotted is D prime on the y-axis in relation to the difficulty level. So 0 being the easiest level, 20 being the most difficult level, where the distractor tones match the target, making it very difficult to identify those deviants. So for each model, we'll go with intensity first. There was a main effect of both level and musical training. So it's nice to know that level did have an effect and it was significant. That just confirmed that the design worked. And then we have this effect of musical training. And so the dense lines performed better than the dotted ones. And our age is plotted based on color. So the dark lines are older adults and the gray lines are younger adults. There were no significant interactions, and an equivalence test for the age effect confirmed that there was no difference from 0. And so that is a true null effect. In terms of spectral envelope, there was again a main effective level and of musical training, no significant interactions, but the equivalence test was inconclusive. So our effect was not significant for age, but it also was different from 0. And so essentially this test was not sensitive enough. For temporal envelope, we have only a main effect of musical training. You can see the slope is quite a bit flatter and performance is actually under 0, under chance most of the time. People had a lot of difficulty with temporal envelope manipulations. And there were significant interactions of music, musical training with level, age with level, and musical training level and age altogether. So essentially, what this tells us is that younger musicians did better than everyone else. They're the only ones that actually were able to perform the task with any success. As I said, we can't compare these directly yet because these three features are not on a common perceptual scale, right? We don't know if a 1 level change in intensity is the same as a 1 level change in spectral envelope or temporal envelope. And so to address this, all right, that's all the numbers, just for interest. I got ahead of myself. So summarizing experiment 1, the musical training effect was replicated, right? Musicians are performing better than non-musicians. There was no main effective age for any feature. We did find that musical training interacts with age for the temporal envelope. It looks similar for spectral envelope, but that wasn't significant. And younger musicians performed best overall for both those things. But again, temporal envelope performance was pretty poor. One caveat we noticed in the end was that older musicians were not necessarily practicing musicians, where younger musicians were. So we do wonder if that might be a relevant effect. So yes, moving then to the dissimilarity rating and MDS study. We use that same 4-note melody with combinations of the 3 features. These are the different levels that were used. They were all combined so that none were alike. We just had everyone rate pairs of melodies on a sliding scale from how dissimilar to similar they were. Again, this is just our participant demographics. The age groups were significantly different. Musical training was not. This was not significantly different, and PTA was. So we did an MDS analysis. There was no difference between age groups here, so they were grouped together. And we just did the analysis on all the participants. And because we have done this, we're able to now recalculate level based on perceptual dissimilarity and rerun the linear models with the addition of feature as a variable, because now we can compare them directly. So these are the results of the MDS analysis. What's plotted here is the correlation between the 3 dimensions found in the MDS analysis and our physical dimensions. So as you can see, they correlate quite well. So on the y-axis, we have our arbitrary unit dissimilarity scale. And using those equations, we can remeasure level based on each feature. So this is our, I think, the more interesting plot, where we have replotted our performance in terms of D prime, but against dissimilarity. So one way to read this is that we can look at a particular dissimilarity point saying, okay, at a rating of dissimilarity 2, the D prime score for temporal envelope, here doesn't exist, is slightly above chance for temporal envelope, but is much better for intensity. And so this is a way for us to see that, which feature is the most salient. In terms of the model and the effects here, there was a main effect of dissimilarity, which is great, and also still of musical training. all interactions were significant except for the age by musical training interaction, which is the one we're interested in. So that was the only one that was not actually significant. I think what's interesting also here to see is that there's a particularly large difference here in older musicians between spectral envelope and intensity, where, say, in younger musicians, that gap is closed. And so older musicians seem to rely a lot more on intensity than anyone else. And older non-musicians to a slightly less extent. All right. So in summary, the maximum difference in features is perceived as most dissimilar for spectral envelope, which is interesting, then intensity, then temporal envelope. And that is actually a nice explanation for why the temporal envelope manipulation didn't work so well and people didn't do as well, because for the maximum dissimilarity between, in intensity, right, between the least loud and the target was perceived as half as different as the maximum dissimilarity possible between spectral envelope ends, and the maximum difference that we manipulated for temporal envelope was perceived as the least dissimilar. And so because they weren't different enough, performance wasn't very good. And so we see again that we have musicians with higher D prime scores at the same similarity levels compared to non-musicians, so we're maintaining that musicianship effect. And like I said, older adults rely more heavily on intensity cues. So overall, it seems like a sequential auditory streaming, especially by intensity, seems preserved in older adults. They're also able to do sequential auditory streaming using spectral envelope, but it's a cue that's used less than younger adults. And we found that age only interacted with musical training for temporal envelope, but the caveat there is that it was poor performance overall, so it's hard to read anything really into that result. Really critically, hearing loss was never a significant predictor of performance. So that's important because we can see that the effects or lack of effects are based on age and not just hearing loss. I think what's really interesting to look into in the future would be to determine whether there's just a lack of deficit and performance is the same, or whether there is a deficit, but there are compensatory mechanisms at work. I think I'm within time. Those are all references that are in there. And I'm going to go back to, I think, this graph to take questions.
Thank you, Sarah, for a very interesting talk, really. So are there any questions? I think in the interest of time, we may have only question for two questions at most.
Sure.
So I'm happy to take any questions in the chat or by raise of hands. I don't actually see anything. May I then ask a question? I was wondering, well, you just revealed, I think in the end, or clarified why the temporal envelope perhaps wasn't as important because the dissimilarity just seemed so small. From the earlier slide you had, I think it was panel B, I think still from Marozeau's stimuli, I noticed also, was there covariation between the length? So temporal envelope involved both the length of the stimulus, but also the amplitude. Is that correct, the way I read that graph?
The loudness was always manipulated so that every sound was perceived as equally loud. Because yes, if you manipulate temporal envelope on its own,
of course, you would need to compensate.
Sorry?
Yeah, so the intent there was to compensate for lengthening the duration by reducing the amplitude that way.
Yes.
Okay. But then that didn't co-vary at the same time with loudness because that was deliberately meant to equalize for loudness. Okay.
Yeah,
that clarifies it. Thank you.
Yeah.
If there aren't any other questions, we'll just move on to the next talk, and any more questions you may have to Sarah, you could just address to her after the session. So our next talk will be by Eddie.